Now let's look at the mistakes people actually make when they write this code. This is the single most common bug in an AVL implementation. It hides in how the rotation result is used. On the buggy side, look at this line. We call rotate right on node, but we throw away what it returns. Then we return node, the old root, but rotate right made a different node the new root, so we just returned the wrong one. The old node now sits one level too deep, with its own left pointer overwritten. The fix is one word, return. We write return rotate right of node. Now the new subtree root travels back to the caller. And that is the rule across the whole function. Every rotation call in AVL insert is either returned like this, or assigned into node arrow left or node arrow right. So the corrected link travels all the way back to the top level caller. What does the bug look like when it happens? Part of the tree becomes unreachable from the root. The subtree still exists in memory, and it is never freed, so nothing crashes. But search no longer finds it, because the pointer that should lead there was overwritten by the rotation and never repaired on the way up. So it looks like some keys mysteriously vanished. It does not look like a crash, which is exactly what makes it hard to find. This is a second real bug. It is about picking the wrong rotation. The mistake. The code always does a single rotation whenever the balance factor is greater than 1. It never checks which side the child leans toward. The symptom. An LR or RL imbalance only gets half fixed. The tree is still out of balance after the so-called fix. The fix. Compare the new key against node arrow left arrow key or node arrow right arrow key. That tells a straight case from a zigzag case before you rotate. Let us try one. A student's code has only 2 branches. If the balance factor is greater than 1, return a right rotation. If it is less than -1, return a left rotation. There are no LR or RL branches at all. For which insertion order from this chapter does this code fail and how? Pause and think. The answer is 30, 10, 20, the LR case. The balance factor of 30 is +2, so the code calls a right rotation on 30 directly. But that applies the straight left-left fix to a zigzag shape. The tree comes out still unbalanced, instead of becoming 20 with children 10 and 30.